In this video, we're going to be solving exponential equations by using logarithms. If using a common base is not possible, exponential equations can be solved using logarithms. So these are the same problems that we solved before, except for now we can't get a common base. And you can see here 3 to the x. We can't write 80 as 3 to the power. Now, if it was 81, that'd be 3 to the fourth, but it's not. So therefore, we can't write them with a common base, so we're going to have to use a different method. And here's going to be our method. Step number one, we're going to isolate our exponential expression. So move anything that's not a number to a power to the other side. Now, step number two, I do a little bit different. You can take the logarithm of both sides, and I'll show you both methods. But what I do is I just change forms. I change from an exponential form to a logarithmic form. So that's either method is fine. Step number three, you're going to expand your logarithm if necessary using the power rule. And then step number four, we're going to solve and check for extraneous solutions. Let's try one. And again, I will show you both methods on this first one, and then you pick the method that you like best. So step number one, you isolate your exponential, and it is 3 to the x power. And the way they do it is they take the logarithm of both sides. Now, it doesn't matter which log you take. You could take log base 10, log base e, but that's the only two your calculator knows, so it probably wouldn't be a good idea to take log base 5. So let's take the logarithm of both sides. That'd be the log of 3 to the x equals the log of 80. You're going to use your power rule to take this x down front. So that'd be x times the log of 3 equals the log of 80. We're now, since these are being multiplied, you're now going to move this over by dividing, and you're done. X is equal to the log of 80 divided by the log of 3, and you can type that straight into your calculator, and you're going to get approximate value for x. Now, we knew that 3 to the fourth was 81, so this should be a little bit smaller than 4. You get about 3.9887. Now, there is a second method for working these, and this is how I do it, and I feel like it's a little bit easier. 3 to the x power equals 80. Simply change forms. That'd be the log base 3 of the value on the other side of the equal sign is equal to x. Once you change forms, and again, this is another reason I like this, it reminds you on how do I type this in? To type this into the calculator, you're simply going to use your change of base formula. That'd be the log of 80 divided by the log of 3, which is the exact same value that you got on the other side, and you're going to get the same 3.9887. Again, I'll work both of these, or work number two both ways, just to remind you again. The first method, we can take the log of both sides. Now, what I would do, since it's a base of e, I would probably take the natural log of both sides. And I'll show you why in just a second. So that'd be the natural log of e to the x, because you can take a log, you can take a natural log, you can take any type of log that you want to. But again, it's best to take either a common log or a natural log. So I have the natural log of e to the x equals the natural log of 140. Move the x down front, so it'd be x times the natural log of e equals the natural log of 140. Now, this is why I did the natural log. The natural log of e right here. Let's talk about what is the natural log of e. The natural log of e says, okay, the base of the natural log is e. So you're saying e to what power is e? Well, that's 1. So therefore, over here, you have x times 1, or just x, equals the natural log of 140. You can type this straight into your calculator now. The natural log of 140, you're going to get about 4.9416. Again, the second method for working these, I'll show you. I just change forms. When you change forms, this would be the log of base e, the base of the logarithm and the base of the exponent is the same thing, of the value on the other side of the equal sign is equal to the exponent. And now log base e, I didn't have to write that as log base e. I could just put ln, and it's the same thing, which to me is a little bit quicker. So I'm going to go with that method, but again, use whichever method that you want to. Number 3, the exponential is isolated, so let's rewrite it as a logarithm. That'd be log base 5 of the value on the other side of the equal sign is equal to the exponent. So what we're going to do is type this into our calculator as change of base formula. The log of 18 divided by the log of 5 is equal to x plus 1. Now, if you want this exact, you could leave it and just move the plus 1 over by subtracting 1. I'm going to go ahead and type in the log of 18 divided by the log of 5 into my calculator. And I get 1.7959 and bring down the x plus 1. Last step, move that 1 over, and it gives you 0.7959 is equal to x. Number 4. Again, let's change forms. This would be the logarithm of base 1/3 of 120 is equal to the exponent. We're going to type this in our calculator by doing log of 120 divided by the log of 1/3 is equal to 2x minus 5. So let's go ahead and type that in. And I get negative 4.3578 is equal to 2x minus 5. Next step, let's add our 5. That would give you 1.3578 is equal to 2x. Last step, divide by 2, and that gives you x is equal to 0.3211. Number 5. Now on these, you do have to isolate your exponential first, so we're going to move this 25 over by subtracting. That gives me e to the 3x is equal to 83. Let's change forms. Log base e, write that as ln, of the value on the other side of the equal sign is equal to the exponent. You could go ahead and get the exact value just by dividing that by 3. Now let me go ahead and show you another way you could write that. Instead of division by 3, you could put a third out front. So you could write that as 1/3. The dividing by 3 is the same thing as multiplying by a third. So you could do that as 1/3 times the natural log of 83, and you could actually bring that up to an exponent then. That'd be the natural log of 83 to the 1/3 power. So that's another way you could write your answer. Or you can type the whole thing in, the natural log of 83, and then divide by 3, and you're going to get an approximate answer of 1.4729. Number 6. Again, let's isolate our logarithm. Let's get rid of isolate your exponential by getting rid of the negative 2. So let's divide by negative 2, and that's going to give me 8 to a power equals 25. Once you get it isolated, change forms. That'd be log base 8 of 25 is equal to the exponent. To type this into my calculator, I'm going to do the log of 25 divided by the log of 8 is equal to 4 minus x. And again, if you want to just type the whole thing into your calculator, here's what I would do. When I see this minus x, again, I always move the minus x to the other side to make it a positive x. The 4 is going to stay put. This whole thing is a single term. Since it is positive, I can move it to the other side by doing minus the log of 25 over the log of 8. Sometimes you're going to have to give an exact answer. That would be the exact answer. If you were to type that whole thing into your calculator, you could do it order of operations if you want to. Make sure you divide first and then 4 minus that answer, but you're going to get 2.4520. Next step, number 7. Again, let's isolate first. Add your 1. That gives you 42. Get rid of 2/3 by multiplying by the reciprocal, 3 halves. Cross cancel gives you a 1 and a 21, so that would be equal to 63. So we now have 2 to the x minus 6 power is equal to 63. Now that's really close. If that were a 64, that is 2 to a power. I believe that's 2 to the 6th power maybe, and that would be much easier to solve that way. So that gives us an estimate of what we're going to have, but we can't do it that way. So what we're going to do, we're going to change forms. That'd be log base 2 of the number on the other side is equal to the exponent. Log base 2 of 63 would be the log of 63 divided by the log of 2 equals x minus 6. And we can move that minus 6 over by simply doing plus 6. That's going to be the exact value. When we type that whole thing in, we're going to get 11.9773. So we have an exact answer there and the approximate. Number 8. Let's isolate our exponential by subtracting 9. That would give me a negative 64. Since the negative 2 is being multiplied, let's divide by a negative 2. And that gives me 4 to the 2x plus 7 power is equal to 32. Now stop for a second. When you see numbers like 4 and 32, let's come over here to the side. I can write 4 as 2 to the 2nd power. That'd be to the 2x plus 7. I'm not sure what I did there. Equals, and 32 is 2 to the 5th power. So we could solve this the other method. That'd be 2 to the 4x plus 14. equals 2 to the 5th, and you can finish from there. Or you can still solve it this new way. That'd be log base 4 of 32 is equal to 2x plus 7. It just tells me that we're going to get a rational answer. Log base 4 of 32 is the log of 32 divided by the log of 4 equals 2x plus 7. We can subtract 7 divided by 2 if you want to, or let's go ahead and type this into our calculator. Log of 32 divided by log of 4 gives me 2.5, which we expect it to be, again, a rational answer, and it is. Subtract your 7 gives me negative 4.5 equals 2x, so therefore x would be negative 2.25. Number 9. 2 to a power equals 2 to a power. Now on these, to me, it might be a good idea on these to save confusion. This is a good one to take the log of both sides instead of changing forms. Just because you have 2 to a power equals 3 to a power, you have a power on both sides. So let's do the log of the left side is equal to the log of the right side. Just saves a little bit of time. You will then take the exponents down front. You'll have x plus 5 out front now, and you will have x minus 2 out front. I should have, let me rewrite that to save a little bit of space. That'd be x minus 2 times the log of 3. Just looks a little bit better. And I can erase that exponent. I moved it down front. And from here on out, it's a little bit tricky. So here's what I'm going to do. I want to write these in exact form just to show you, just to give you a little bit of extra practice with some stuff here. We're going to take this and distribute it. We're going to do x times log of 2 and 5 times log of 2. That'll be x log 2, or x times log of 2, plus 5 times log of 2, equals, same thing on the other side, x times log of 3, minus 2 times log of 3. Okay, now here's the problem. We've got to solve for x, and I've got 2 of them. Anytime that you have an equation, this is not quadratic, this is linear. Anytime that you have an equation that has 2 x's, you always like to combine those x's. But how in the world do you combine log 2 and log 3? Here's what we're going to do. Move everything with an x to the same side. So we're going to leave the x times log of 2, and we're going to move this term, which is a positive, over here by doing minus x times log of 3. Anything that does not have an x with it, we're going to move to the other side. So this positive 5 log 2, we're going to move over here by doing minus 5 times log of 2. And you already had the minus 2 times log 3 over here. And here's why we did this. Our x's are on the same side, and we can't, there's no like, or they are like terms, but how do you combine them? What we're going to do is we're actually going to factor out the x, which is just like combining them. And you're going to be left with log 2 minus log 3. And the reason we did that is because we have gone from having a 2x's to a single x. And on the other side, you have negative 5 times log 2 minus 2 times log 3. And now to solve for x, we're going to simply divide. Since these are being multiplied, we're going to divide by this whole term. So x is going to equal negative 5 log 2 minus 2 log 3 divided by log 2 minus log 3. That is an exact answer. Now, you could clean this up. Reminder, and I think I missed, no, I'm good. These values here could be moved up into exponents. So you could write this as the log of 2 to the negative 5 power and minus the log of 3 squared. You could do that. Or what I'm going to do now is probably just type this whole thing into my calculator. As you do that, make sure you put the top in parentheses. That's a parentheses. And you put the bottom in parentheses just to be safe about your division. But you should get an approximate answer of 13.97. Next up, number 10. Same thing. We're going to take the log of both sides just because it's easier on these problems to do so. And I'm going to leave a little bit of space because I know that once I take the log of both sides, I'm going to move those exponents down front. So I'm going to leave some space out front. That'd be the log of 5 raised to the x plus 3. Again, bring the exponents down front. You have the 2x minus 1 out front now and the x plus 3 out front. Make sure I put it in parentheses because I've got to distribute those to each of the logarithms. 2x times log of 8 would be 2x log 8. Minus 1 times log 8 would just be log 8 minus log 8. equals x times log of 5 is simply x log 5 plus 3 times log of 5 would be 3 log 5. Every logarithm that has an x, there's 4 terms there. Every logarithm that has an x, let's move it to the left side. I already have this one over here. So let's move this one over by doing minus x log 5 equals everything that doesn't have an x, let's move it to the other side. This 3 log 5 is already over here. Let's move the minus log 8 and by doing plus log 8. And again, any of these, like the 3s, you could move those up to an exponent if you would like to and clean that up. It doesn't really matter because we're going to type it into a calculator. I just want to remind you that it is possible. Our x's here could be factored out. I'm left with 2 log 8 minus log 5 equals 3 log 5 plus log 8. And the very last step before I use my calculator, since these are being multiplied, I'm going to mark it out and I'm going to divide by it. So divide by 2 log 8 minus log 5. And again, that's the exact answer. Another way to write that exact answer could be the log of 5 to the third plus the log of 8 over the log of 8 squared minus the log of 5. And also a reminder, you could actually use your rules of logarithms there. You have a log plus a log on top. You could write that as, this is not necessary because you're typing it into the calculator, but you could write that as the log of 125 times 8, which is the log of 1,000. Over, and the reason I'm showing you this is it's a good extra practice for like ACT type material. The bottom, the log of 64 minus log of 5 could be written as the log of 64 fifths. The top, the log of 1,000, you actually know that's a base 10. That's 10 to what power is 1,000? So you could clean that up completely by just writing a number 3. So these can be cleaned up further without a calculator. But when you type any of these values into the calculator, you're going to get an approximate value of 2.71. Number 11. Same thing, take the log of both sides, the log of, and leave yourself some space, I keep forgetting. The log of 4 to a power equals the log of 11 to a power. Move your powers down front, and again, I didn't leave enough space, so I'm just going to rewrite it. X minus 3 times log of 4 equals 3x plus 2 times log of 11. Distribute, that'd be x times log 4 minus 3 times log 4 equals 3x times log 11 plus 2 times log 11. Anything that has an x, let's move it to the same side, x log 4. Let's move this term over by doing minus 3x log 11 equals 2 log 11 is already over there. And again, if you want to write that, you could bring that 2 up here, and just to save some writing, you could write that as log of 121. This minus 3 log of 4 is going to turn into plus 3 log of 4, and you could bring that 3 up front. That's going to be plus the log of 4 to the third, which is 64. So you can write it either way, okay? Factor out the x, you're left with a log 4 minus 3 log 11 equals log 121 plus log 64, which again could be combined if you would like to. Move this whole thing, since these are being multiplied, let's divide by log 4. Minus, you could do the log 11 to the third, but again, it's being typed into your calculator, so 3 log 11, mark it out. When you type all this value in, you're going to get x is approximately negative 1.54. And the next one. 9 to a power equals 2 to a power. Now, again, reminder, if this was something like 3 to a power, both of these could be changed to the same basis, but as is, they cannot be. So you have the log of 9 to a power equals the log of 2 to a power. The powers can be moved down front, and that's linear now, or excuse me, it has only one term. The 5x plus 4 has 2 terms, so it does have to be distributed. You have negative 2x log 9 equals distributive property on the other side, 5x log 2 plus 4 log 2. And I'm not going to rewrite any of these. We're typing it all into the calculator anyway, so that's fine. Anything with an x gets moved to the same side. So we now have negative 2x log 9 minus 5x log 2 on the left side, and simply the 4 log 2 on the right side, which is the same thing as log 16. Factor out the x over here. You're left with negative 2 log 9 minus a 5 log 2 equals 4 log 2. And the last step, to get x by itself, we're simply going to take our 4 log 2 and we're going to divide it by this side, everything else, which is negative 2 log 9 minus 5 log 2. That's an exact answer, or you could clean it up some. Type that into your calculator and you get approximately negative 0.35. So again, here's your exact, there's your approximate.